by distance from a bench. So this one who's doing some bench presses, that's what I would be saying, right? And so our next graph is going to be the distance from the bench. So when we set up our graph, we're going to label our axes, and it should look just like this. So it's distance from the bench in feet. The scale on this one is a little bit different. It goes half a foot, then a foot, then at 1.5 feet, then 2, 2.5 feet, then 3, 3.5 feet, then 4, 4.5 feet, then 5. So we're going to watch it in real time, and then we're going to watch it in halftime a couple times. So we're going to take a moment to make sure that our graphs are set up, and then we're going to watch it. Here we go. So this is regular speed. All right, so here we go. We're going to go in half speed. It's kind of crazy watching him struggle a little bit at the end. I want you to figure out, where is he starting at 0 seconds? How far is this bar right here from the bench? How far is the bar from the bench?
The bench, the bottom.
Like where his shoulder blades are, like right here. So give your best guesstimate. We don't have anyone measuring it, so we're just gonna have to guesstimate, which is totally fine.
Are we going halves on this?
Sure. Do halves?
Like 2.5?
For sure. Why not? I think that's a great idea. Do what works for you. All right, here we go. This is going to be in half speed. Plotting your points as you go. He's struggling a little bit. He needs a spotter. All right, we're going to watch it again because we want to make sure, you know, it's hard to get all those points down right away at the beginning. So let's watch again. Oh, I should probably hit play. Here we go. All right, one more time we'll watch it. See what your graphs turn out and compare it. Here we go. And then we'll connect your dots to kind of show a smooth transition as it's moving. All right, so let's take a look at what the graph is that they came up with and compare it to our graph. All right, so when you're looking at your graph, it doesn't matter to me much about where you started or where you ended, if you started at 2 feet or if you started at 3 or started at 4. What I would look at if I was looking at your graph are your peaks all at the same value. So in this case, they're all at 3. If you started at 2.5, are they all at 2.5? And are your valleys at the same point? So this is 1.5. If you're at 2, if you were at 1, that doesn't matter. But do you understand that the highest you go is the highest you go every time? The lowest you go is the lowest you go every time. When he was struggling, when I did this, I had a little more zigzaggy than what they've got, but nonetheless, it shows some struggle here. And then we're ending again where we started. So keeping that point in place. So a little different graph. Didn't really have any pauses. It's connected, but looking to make sure your peaks are all consistent and your valleys are all consistent. That's what I would be looking for on this graph. Let's try one more. Let's do balloon length. Okay. So this one right here is going to compare two variables. It's going to compare time, which is what we're controlling, and it's going to compare the length of the balloon. And so as we go through graphing this one, the first thing we're going to do is set up our graph, and our axes are going to be balloon length in inches and time in seconds. And when you look at this particular scale, it goes up by 1.5. So it's 1.5, 3, 4.5, 6, 7.5, 9, 10.5, 12, and so on. So I'll give you a moment to get your graphs set up. And we're going to watch the balloon length. We're going to watch it the first time, and then we'll graph it when it's in slow-mo the next couple times. Here we go. And again, we're trying to take a scenario and represent it as a graph.
Then what's wrong?
All right, are you ready? We're going to do it in half time right here. Okay, so think about at 0 seconds, how long is that balloon? Start with that point. Okay, and we don't, again, have anyone with a ruler there who's measuring it, so you're giving it your best guesstimate. All right, let's try it again. Slow motion, length of the balloon. Watching the time in the lower left. Remember when you're like 2 years old and someone would do that with a balloon and you'd laugh uncontrollably because it was so silly? Oh. All right, one more time. Here we go. All right, so let's take a look. I'll give you a minute to kind of adjust I'll give you a little time to kind of adjust your graph. And we'll take a look at what they have. All right, here we go. Let's take a look at the graph that they came up with.
Then what's wrong?
All right, so as we look at this graph, again, I'm not so concerned about your measurements because nobody's there actually measuring this balloon. What I'm concerned about is, one, does it start and end at the same measurement? So when you start, there's no air in the balloon, really, I guess. And at the end, all of the air has come out. So are your ending points and start and end points similar? Also, do you show some breaks, some horizontal lines in your graph? When he's when he's inhaling, getting ready to blow some more air into the balloon is not increasing in size at that point. So these horizontal lines represent when he's taking a breath, or when he's not blowing into the balloon, or when the balloon isn't getting any bigger. I mean, there's so many different ways that you could describe that, really, but the exact same thing that's going on. And so I'd be looking to see, okay, are there some horizontal lines in there representing that he's taking a breath? And then this last line should be fairly consistent because the air should be coming out at a pretty consistent rate. And that's what I'll be looking for. All right. So what we just did is walked you through some examples of taking a real life scenario and representing it graphically. And throughout this year, we're going to be working on graphing, t-tables, equations, and then story problems. And how can we move between those four forms of functions smoothly? Right now, it's going to be a little rocky. We're hoping by the end of the year that it's pretty smooth, that we could give you a story problem and you could write an equation, create a t-table, and graph it. Or that we could give you an equation and you could graph it and have a t-table and write a story to go with it. Okay? So before you, what I want you to do is make sure you get a picture of this and submit it into that. And this is the lesson on graphing stories. There we go. Stop recording.